Hello and welcome to today's lesson, which is an introduction to motion in the forces topic. So today's lesson, where we're going to try and understand speed in a distance time graph, is part of the AQA Separate Science course in physics in the forces module. So we're going to try and describe speed, velocity, distance and displacement both in words and mathematically, understand how to interpret a distance time graph, and understand how to retrieve information from looking at a distance time graph, which links into the following part of the AQA GCSE specification for separate science physics in the forces module, which is found in paper 2 of the GCSE examination. So we're going to look at the distance and displacement part of the specification, the speed part of the specification, which links into the equation and the definition of the word speed, and then finally look at what velocity is and the distance time relationship. So, speed is a quantity discussed in a lot in everyday situations. Now, speed does not involve direction. Speed is in fact a scalar quantity. Now, the speed of a moving object is rarely constant because when people walk or run or travel in a car, their speed is constantly changing. And when you're walking or when you're cycling or when you're running, there are many factors that can affect the speed at which you go at, including your age, the terrain in which you are doing the exercise upon, your natural level of fitness, and the distance you have travelled. So what do we mean by the word speed? What's our definition of speed in words? Well, speed is a quantity measuring the distance an object covers in a certain time, and there are many measurable speeds in the world. So, for example, the walking speed of a human typically is 1.5 meters per second. The running speed of a human typically is 3 meters per second. The cycling speed of a human is approximately 6 meters per second. The speed of a car is approximately 14 meters per second. The speed of an aeroplane about 280 meters per second, and the speed of the Earth orbiting the Sun is about 30,000 meters per second. Now, you've got to remember these different speeds for your examination, so you're expected to be able to estimate all those different speeds. But always remember that speed does not involve a direction, it's in fact a scalar quantity, and the speed of all objects rarely stays constant. So this is an average speed, because throughout a journey, whether you're walking, running, cycling, or in a car or in a plane, you're not going to keep the same speed throughout your journey. Now, like we said before, the speed of a human can depend on many different factors. Now, objects can also vary their speed through their journey. So it's not only moving objects that can have a varying speed, but the speed of sound and the speed of wind can also vary. So a typical value for the speed of sound in air is 330 meters per second, but the speed of sound varies on the density of the materials traveling in. So the denser the material, the faster the speed of sound. So sound travels fastest in solids like iron or wood, but will travel the slowest in gases like air. So in fact, the speed of sound in air is actually one of the slowest speeds of sound possible. Now, how do we calculate these speeds, and what does the unit of meters per second mean? Well, we can calculate speed with the following equation. Speed in meters per second is equal to distance travelled in meters divided by time taken in seconds. Now, in everyday life, we tend to use the units of kilometers per hour or miles per hour for speed, but in physics, we tend to use the units of meters per second. Now, this is an equation you've got to memorize for your examination, and you've got to be able to rearrange this equation as well. So make time the subject, make distance travelled the subject, and you've got to work out the units for your speed. Now, the units for your speed are the units of your distance divided by the units of your time, and this will work out the average speed of an object with the correct units. Now, just remember that because we tend to measure distance in meters and time in seconds, that gives us a scientific unit of meters per second for your speed. But if your distance travelled was in kilometers and the time taken in hours, that is when your speed can be in kilometers per hour. Now, just remember that if you've got a constant speed, the object is starting from rest, the final speed is always double the average speed. That's because the average speed is the middle value of speed for that particular journey. Because if you start your journey at 0 meters per second and end your journey at a certain value of meters per second, say for example 20 meters per second, well then the average speed is between 0 and 20, so 0 plus 20 divided by 2, which would equal 10, which is the middle value. Now, if an object is moving along in a straight line, well then the distance can be represented by a distance time graph. So in these particular graphs, you plot the distance on the vertical axis and time on the horizontal axis. Now this is one of the only graphs in science where you do not draw a line of best fit. You draw a line plot to plot. That's because this graph is showing the journey of an object travelling, not a trend of variables. So you would never draw a line of best fit on a distance time graph. So the speed of an object can be calculated from the gradient of its distance time graph. Now you should remember that the gradient of a line is the change in y value divided by the change in x value. So in this instance, it's the change in distance over the change in time, which is going to be the speed. Now when calculating the gradient, always draw a gradient triangle as it shows the values that you are using for your particular calculation, and your gradient triangle should be as large as possible. As the greater the range of values used, the more reliable your result. But this method can only be used if the object has a constant speed, because you need a straight line of best fit to make a gradient triangle. Now, like we said before, it's one of the only graphs where you must join the plots and not draw a line of best fit, because you're plotting the journey of an object and you're not looking for a trend. Now, if an object is changing speed, it's accelerating or it's decelerating, the line of the distance time graph will be curving, as shown like this. So a line curving upwards shows the object accelerating. Now if an object is accelerating, its speed at a particular time can be determined by drawing a tangent and measuring the gradient of the distance time graph at that particular time. So a tangent is a straight line that touches a curve at a point, but if extended, does not cross it at that point. So for example, this is a tangent drawn at 10 seconds. So it's a straight line that only touches the curve at 10 seconds. So to work out the gradient of your tangent, it's the same principle as before. You draw your gradient triangle with the tangent forming the hypotenuse straight line, and you repeat the same calculation. Change in y value over change in x value. So here are the following sections on the distance time graph and what they show. Now just please remember, you cannot go down on a distance time graph. You can never decrease your distance. So a straight line going upwards shows the object moving at a constant speed. A flat line along shows the object stationary. A line curving upwards shows the object accelerating, and a line curving downwards shows the object decelerating. Now you will notice that the line can never actually go downwards. Now that's very, very important, because the line can never go downwards, because distance is a scalar quantity. So you can't get a negative value for distance. It can't go down. It can only go up. So because distance is how far an object moves, so it can't decrease in a journey. Even if you're coming back on yourself, you're going back to where you started, you're still increasing your distance, how far you've actually moved. Now, the quantity which considers the direction you've been placed in, so is now a vector, is called displacement. So displacement is the straight line distance from the start point to the finish point of a journey in the direction of that straight line, and it's a vector quantity. Now, if a distance time graph shows a line going downwards or is in fact negative, it's in fact a displacement time graph, not a distance time graph. So just to make sure that there's a clear difference between distance travelled and displacement. So, distance is a scalar quantity. It's a measure of the total length you've moved. But displacement is a vector quantity. It's a measure of how much the straight line distance is between the start and the final point of your journey. So remember that distance and displacement are both measured in meters, but distance is given a symbol of d and displacement a symbol of s. Now that is because one is the scalar and one is the vector. So displacement can be expressed in terms of a magnitude and a direction because it's a vector. So you can denote the direction with either a plus or a minus, allowing in a displacement time graph for your line to be negative and go downwards. So let's just see the difference between two particular ideas. So a velocity of an object is the speed of an object in a given direction, and velocity is a vector quantity. It's the rate of change of displacement, because displacement is a vector, allowing velocity to be a vector. So velocity is the change in displacement divided by the change in time. And we can represent direction by either positive or a negative sign. Speed is a scalar quantity. It's the rate in change of distance of an object. Now we're using distance because distance is a scalar, allowing speed to be a scalar. So speed is equal to change in distance over change in time. Now speed does not have a direction, so it can only be a positive value and never a negative one. Now velocity is a much more useful quantity than speed as it contains more information. That plus or minus is indicating the direction, and this can be very important in many different situations. So for example, let's say you've got two cars travelling and they collide head on, so they must have been travelling in opposite directions. Now because they are travelling in opposite directions, one of them must have a negative velocity. It actually doesn't matter which one, as long as you choose one of them to be negative. So now you've got one travelling at 30 meters per second velocity wise and the other travelling minus 31 meters per second velocity wise. So therefore the difference in velocity is 61 meters per second, because the difference between 30 and minus 31 is 61, and that tells us why a head-on collision is actually very dangerous, because there's a large difference in velocity. But by contrast, if you now look at a crash where a car goes into the back of another car and like bumper to front, they don't tend to be as bad. Well, why is that? Well, it's because that now both cars are travelling in the same direction. They've got to have the same sign. So let's say they're both positive. So now we've got 30 and 31. So what's the difference in velocity? Well, the difference is now 1. So actually that implies why actually these type of collisions are not as dangerous as head-on collisions, because there's a very small difference in velocity. Now, if we didn't know about the direction, if we didn't incorporate a plus or minus into our values, we wouldn't be aware of this, indicating why velocity is so important. So velocity is the speed of an object with a direction, or you consider a change in displacement. Now, any quantity in physics with a direction is called a vector, and we can illustrate velocity by either stating the direction of travel or with a plus or a negative sign. Now, you can decide which direction is positive and which direction is negative, but they've got to be opposites of each other. So if you define going upwards as plus, well, going downwards must be negative. So it doesn't matter which direction is going to be defined as a positive as long as the opposite is a negative. So if we define going to the right as a positive, well, going to the left must be a negative. If we define going to the left as a positive, going right must be a negative. If we define going up as a negative, well, down must be positive. So that is an important idea in terms of velocity. Now, if an object is moving in a circle, it can have a constant speed, but it must be changing velocity, because velocity is a speed in a given direction. Velocity has a direction component. So if an object is moving in a circle, it's constantly changing direction, so it means it's constantly changing velocity. So an object going around in a circle must be accelerated, which we'll look at in a future lesson, as it's extremely important in terms of forces. So let's have a look at what we've learned in today's lesson. Distance is how far an object moves, and distance does not involve a direction. Distance is a scalar quantity, but displacement includes both the distance an object moves, measured in a straight line from the starting point to the final point, and the direction of that straight line, and displacement is a vector quantity. The speed does not involve a direction, it's in fact a scalar quantity. The speed of a moving object is rarely constant, so when people walk, run, or travel in a car, their speed is constantly changing, and the speed at which a person can walk, cycle, or run depends on lots of different factors like the age, the terrain you're on, your fitness, the distance you've travelled. Typical values can be taken as walking speed is about 1.5 meters per second, running speed is about 3 meters per second, cycling is about 6 meters per second. Now, the speed of sound, the speed of wind can also vary, but the typical speed for sound and air is 330 meters. We can work out speed by saying speed equals distance over time, or distance equals speed times time, and the velocity of an object is its speed in a given direction, and velocity is a vector quantity. But motion in a circle involves constant speed but change in velocity. So if you've learnt in today's lesson, and when an object moves along a straight line, the distance travelled can be represented by a distance time graph. The speed of the distance time graph can be calculated from its gradient okay, from the distance time graph, and if an object's accelerating, its speed can be determined by drawing a tangent and measuring the gradient of that tangent. So if we've learned in today's lesson, we can describe speed, velocity, distance and displacement in words, and with mathematics we can understand how to interpret a distance time graph, and we can retrieve information from a distance time graph. I hope you've enjoyed this lesson, which is an introduction to motion, which is found on GCSE Separate Science Physics. Thank you and have a lovely day.